Hello everyone, we will solve this today's LeetCode problem. The question is minimum cost to convert string 1. This is a LeetCode medium one. Let's see what the question is asking. So we have given a zero index strings, source and target, both of the length n and consisting of lowercase English letters. We are also given two zero index character arrays, original and changed, and an integer array cost, where cost I represent the cost of changing the character original I to the character changed I, right? So basically, we need to change the source string to the target string, and we have given characters, right? That how much cost it will take to convert this original to change, right? So we have to start from the string source, and in one operations you can pick a character x from the string and change it to the character y at a cost of z, right? And if there exists any index j such that cost j is equals to z and original j is equals to x and change j is equals to y, so we need to return the minimum cost to convert the string source to the string target using any number of operations. Okay, so basically there is a source given and the target given, right? So we need to convert this source to target, right? by changing by changing by changing each and every character to the target, right? Each and every character to the target. So basically, and we have given the character which is original and the changed character vector, and we need to change this original to change in terms of this cost, right? That original I is can change I in terms of this cost I, right? And this cost should be minimum. This should be minimum according to the question, right? So basically, we need to convert this source to target, and we need to overall find the minimum cost, at how much minimum cost we need to take for converting this source to target, right? This is the question basically, right? So if you see the source and the target, one thing is also given here, that it can be possible that there can be multiple possibilities, right? A to B, and the cost is cost is z, cost is x, and same for a to b conversion, the cost is y, right? So we need to take the minimum one. The minimum cost is it this case can be possible, which is written in this question, right? So it is possible, this case can be possible, right? So we will remember this case in this, right? Okay. And one thing to note here, that okay, that's the thing which we need to note here, right? And this source target original, let's take this as example and understand the question. So basically, we need to convert this from abcd to acbe, right? And this original is abcd to change to bcbbe, and this is the cost conversion. So a change to a, that doesn't mean anything, right? We don't need to change anything, but we need to change from b to c, right? So how many, what is the minimum cost it can take? So if you see, the original b can to change c, right? This b can change to c with the cost of 5, right? So this takes cost 5, right? Again, there can be possibilities, right? That this is the 5, right? And we can't take any paths to convert this b to c, right? Again, from c to b, right? C to b conversion, how much cost it can take? So c is here and b is here, and the cost is 5, right? The cost is 5. But if you see, this is the direct conversion from c to b, right? This is a direct conversion. But if we take not a direct conversion, just take c to e, and then from e to b, right? C to e, just make this as a string, and this is make as a string, right? Right. So if you see, from c to e and then e to b, I can go there. I change c character to e, and then I can change e character to b. So c to e conversion takes 1, and e to b character takes 2. So 1 plus 2, so 1 plus 2 is equals to 3, which is minimum, right? So conversion from c to b with this path takes 3, and conversion from c to b with this path is take 5. So this is the minimum cost we need to take. So what will be the answer? So answer will be the 5 plus 3, b to c 5 and c to b 3, right? Plus d needs to change to e, right? So d is here and d needs to change to e, which takes 20. So basically d to e is 20, and answer would be 20. So this will be 28. So if you see, the answer is 28. There is no any other path which can convert D to E, right? Less than this cost, right? Okay. One thing to note here, this is the first case, right? This is the first edge case. The second case can be possible that if we are not able to, if we are not able to convert any character to target character, then it means we're not able to change it, so we will return -1 in this case. In this case, then we will return minus 1 in this case, which is given in the question, right? If we are not able to convert source to target, we will return -1 simply. Okay, so these are the two edge cases we need to keep in our mind. Now the main thing is that how we will calculate it. So if you see here, that basically it's the question of that how we will convert any character, how will you convert any character to some other characters in minimum cost, right? This is the minimum thing. So if we take analog with the distance something, right? Distance something, the cost takes analog, take the cost analogy to cost analog to distance. So yesterday's we have solved some one problem, right? Yesterday we have solved some problem, and you can see that this can follow any path, right? This can follow any path. So think, can we think it is like a graph? Can we think it like a graph? If you think like a graph, the nodes are here, the characters, alphabet characters, A to Z, right? A to Z are the nodes, and the edges would be this original and the change, right? The connection between the original and the change. So this org I to change I is the edge with the weight as cost I, right? Or you can take it as a distance I, whatever you prefer, right? So basically we need to know that which character, from character, any character to change to any character, this needs to be changed to this needs to be changed to so basically this needs to be changed from in minimum cost, right? Minimum cost. So yesterday we have solved some problem that for each and every node, right? For each and every node, we need to convert it, so what are the algorithms we need to find? So if you see, total nodes, the total number of nodes maximum is 26 possible alphabet side. So any algorithms, any shortest algorithm which can solve this problem, because this is the number of nodes is very smaller, right? The number of nodes is very smaller, so any such algorithm is applicable. Either you can use Dijkstra, or you can use the Floyd Warshall, which we have used yesterday, right? Anything you can use, the Floyd Warshall, Dijkstra, anything you which you want, right? And we can solve this according to anything, right? So we will use Floyd Warshall again. So Floyd Warshall, what we do, we take an intermediate node, right? In Floyd Warshall, we take an intermediate node, and we can take intermediate node as a help to find the minimum distance between find the minimum distance, or in here in this case cost, right? Cost to between two pair of nodes is here alphabets or characters, anything you tell, right? So this is the Floyd Watson, right? Basically something like this, like this is the first node, and you take help of a k node, which is intermediate node, and you need to find the minimum distance between 1 and 2 to convert it, and this k here is intermediate node, right? So basically for finding distance between 1 and 2, you find the distance between 1 and k plus distance between k and 2, right? And k will vary from k can vary from 0 to any nodes, right? Any node, the number of nodes, right? So the minimum which we get from this all k will be the answer for distance 1 to, right? This is the Floyd Warshall algorithm, and we will use this, right? So what the benefit of this, that I know all the distance, all the cost of converting any character, any character to any character, right? I know all the cost of converting any character, and which will the minimum cost for sure. The main motto is minimum cost, so that will I know after using this Floyd Warshall for converting any character to any other character. And you know that I need to just change this source to target, right? ABCD to ACB, and just we will just add all the minimum distance, minimum cost, which needs to take the conversion from source to target, right? From source to target, and return the answer, right? Return the answer, the summation of all cost as our answer, right? That will be written here. So this is same as Floyd Warshall algorithm. We have solved it yesterday also, and I will show you the how it is work. But just it is something like we take all the we find all the distances for each character to every character, and the total node is 26. So you can use any sort of algorithm. All will work because the constraints is very low, right? 26 is very low. So we will take the help of each and every node to find the minimum distance, and this is the Floyd Warshall algorithm. So this is how we solve this question. The main thing is to think of this question as that this question be solved as a graph. And how will you know that? You should click here that we can move. We need to move from original to change, and we can have many paths, not direct paths. We can have any path, right? A, B, B to C, C to B, anything. And the cost which is minimum should be stored for that conversion, and there you need to click that this question can be there can be of a graph, right? And this is how we solve this problem. So let's just implement it. And yeah, the first thing is to find the distance, right? So we will find the distance for each and every node. So there can be possible 26 nodes, right? Alphabets. And that 26 node maximum value can be. So if we need to see the constraints here, right? So constraints are the cost length can be 2000, right? This can be 2000. And this answer is we need to return long, right? And it is 10 to the power 5, so uh, it can go to 10 to the power 8 or 9 something. So just take it as a long, right? So we will define, although I need to also return it as a long answer. So let's do it in long, right? For safer side. So let's just make it as long data type, and this can be intermax, right? This is the maximum it can go, or you can take it as 1e12 also. Anything you can take, right? So I take 1e12, right? So let's just start using Floyd Warshall. So for Floyd Warshall, you need to find the distances of all. So distance for each node to to itself is zero, right? Distance of each node to itself is zero, right? There can be no cost to change, right? Also, so I'm taking distance, but it is analog with the cost, right? It is analog with the cost, right? So also this original to change is something like ages, right? This original is mapping to change, so this assume as ages, right? So that would be end n, or you can take it as m, and this will be original dot size, right? This should be less than an I plus plus. Now the original is the original is the source, right? So it will be the source original, or you can take it as a from, right? Anything you can take. So this is just an implementation. How will you implement it? You can use anything, and this is 2, and this will be changed, right? And this needs to be marked as this okay, this to be from to 2, and this will be the minimum of. Okay, why I'm taking minimum? Because I told you that it can be possible that there are multiple weights possible for there are multiple weights possible for the same changes, same ages, right? So we need to take the minimum of distance from 2 to, and this is cost, right? And this is the cost, right? So we need to take just a minimum. And so till now we have inserted all the cost and the direct changes. Now we need to find the minimum cost for each and every character. So what we have done, we will take the help of each and every node as an intermediate. So that will be k to 26 and k plus plus, and same thing goes on here, int I 0, int I 26, and this is I plus plus, and same is j 0, j 26, and this is I plus plus. Now we just need to take the minimum of aj with the help of what? With the help of k, right? One thing to note that why have yesterday I have asked I have asked you one follow up question, that why I have taken this k, which is an intermediate node, at first point, not at the last or in mid. The main reason is that for each and every intermediate k, this I and j, this I and j will always change, right? So in future, suppose distance and suppose in future, suppose we need to find the distance between 1 and 2, and we are finding it using help of 1 3 plus 3 2, right? So before we have calculated 3 2, which was not minimum, right? Before we have calculated 3 2, which was not minimum. So we have 3 2, which was not minimum, but after in future it get updated, right? It get updated. So if we don't update I and j for each and every k, then in future this will not be get updated for 1 2, right? And suppose for 3 2, initially we have assigned some values, but that was not minimum, but after some changes this 3 2 will get minimum, but this 1 2 will not get assigned to minimum, because before it was not updating. So that's why for each and every intermediate node I am changing I and j simultaneously, right? That's why this I and j is under the intermediate nodes, right? That's the reason for intermediate nodes, right? Hope you know before yesterday, right? So that's the question, and that's what the follow-up question answers. Now this distance ij is stored all the distances for conversion for each and character to every character. Now we just need to submit for source to target, right? This is just a Floyd Warshall algorithm. Now we know for solve the problem, we will start iterating for, okay, this should be m, right? This should be m, and now this is n. This will be the source dot size, source dot size. Now what we will do, we will again iterate in this, and if this source I is this source I, distance source of I to distance or a target I, which will be you can take it as a integer. So this is character, so we need to convert it in integer. So that would be minus a, and the same goes for destination, which is target I, right? So this will be the source and this will be the distance, right? And this how what we will do, we need to store in this. So that's answer will be should be in log of an log long. So this is answer plus distance, answer plus distance, right? This is the distance. Like, in one two thing to know, that what if this source to destination is not possible, the conversion is not possible. So in that case, this distance source and destination would be 1 e12. If the conversion is not possible by following any path, this conversion will be this should not be possible. So if we need to check that, so if this source and the destination is equals to 1e12, so it means we need to just return -1, because we can't change this source to target, right? So this is how we solve this problem, and at last we just return answer. Let's just try to run this, then we will conclude it. Something is missing. 19 number 15 from to the cost I. Okay, so the problem is the distance is long and this cost is int, right? So that's why this is so we need to typecast this cost to long, right? Just multiply it with 1 ll, or you can like write like this also, right? Anything which you prefer, right? So let's just run this. Yeah, we have passed the sample case. Let's submit it. Yeah, we have passed all the test cases. So basically what we have done, we have find all the minimum distances from each character to every character using Floyd Warshall algorithm, and then we have checked that for each source node to each source character to each target character, if the conversion is possible, it means if there is a distance, then we will just store it an answer. Otherwise, if it is not possible, then we will return -1. That's the question, right? So that is the question. And so the space and the time complexity is same according to Floyd Warshall, right? So that is 26 into 26 into 26. Also, uh, this can be go to till O of target source length O of n for this, right? And this is 26, so you can take it as 100 20 is 4, and this is 2 to the 4 to the 8,000 something, right? So 10 to power 3 something, right? So basically it can be go to 26 ka cube, 26 cube plus O of n, which is the length of source and the target string, plus O of m, which is original length and the change length or size of this, right? So n is the size of a string, size of source string, and m is m is the length of or size of array, size of original array, right? So this is the time complexity, and the space complexity is that we have taken only a distance extra array for storing the cost, right? So this must be named as a cost, but I have made that a distance, so this can be only the cost, so that will be O of 26 k square, right? That would be 26 k square, and we haven't taken any extra uh, spaces, right? This is a variable, and this, yeah, we haven't taken any extra spaces other than this. So this is the time and the space complexity for this problem. Hope it helps, and thank you so much. Bye bye.